Good afternoon, everyone. I am Naveen Shankar Choudhury, and today I will be giving a presentation about application of context-free grammar in natural language processing. So the topics of discussion today would be first, I would just give a brief introduction of what is context-free grammar and what is natural language processing. And most important thing is how this CFG is used in natural language processing. So multiple ways, what are followed, those things I'll be discussing about it. And two of the most prominent ways, which is parsing and grammar-based text generation. I'll also be discussing about that in detail. And finally, I would like to conclude with the limitations, which is present in CFG, especially how the limitations exist in NLP using the CFG, right? So yes, starting off the introduction. What is NLP, right? And what is CFG? And I would come to that. But before that, natural language processing is a field of computer science that aims to enable computers to understand and generate human language. Context-free grammar is a powerful tool that has been used in NLP to model the syntax of languages. This presentation will explore the potential of CFG in natural language processing. So what is context-free grammar? So context-free grammar, that is CFG, is a formalism to describe the syntax of languages. It consists of a set of production rules that generate sentences by recursively replacing non-terminal symbols with a terminal or non-terminal symbols. CFGs are used in various NLP tasks such as parsing, which we'll be discussing, where the goal is to determine the syntactic structure of a sentence, or generation, where the aim is to produce grammatically correct sentences. They provide a formal framework for analyzing and generating natural language sentences, capturing important aspects of syntax and grammar. CFG thus has been used in NLP in multiple tasks, and the two most prominent ways is parsing and generation, which we'll be discussing in detail in this presentation further. So, what is context-free grammar, as I had already discussed, but how is it represented? It is defined by four tuples: T, which describes a finite set of terminal symbols; V, which describes a finite set of non-terminal symbols; P, which describes a set of production rules; and S, which is the starting symbol. In CFG, the starting symbol is used to derive the string, which we can derive the string by repeatedly replacing a non-terminal by the right-hand side of the production until all the non-terminal have been replaced by terminal symbols. Next, what is NLP? Right, it's something which is used. The terminology which we hear very often is used really well in this everyday life. We hear about it every day, right? So NLP is nothing but it's a fascinating field of artificial intelligence, and that has been gaining a lot of attention in recent years, right? So NLP focuses on enabling computers to understand, interpret, and generate human language, which has many practical applications, obviously. And for example, speech recognition, language translation, sentimental analysis, and chatbots. So, well, chatbots is something which all of us know, right? And yes, so these are all the areas where NLPs are applied. And NLP uses a range of techniques from linguistics, computer science, and mathematics to analyze and process natural language processing data, making it a complex and very interesting and fascinating field of study. So the one of the most important topics again is how is CFG, the application of CFG in natural language processing. So CFGs have a significant impact on natural language processing in several ways. First, parsing. CFGs are extensively used in syntactic parsing, which involves analyzing the structure of sentences and determining how words combine to form phrases and sentences. This is done by specifying production rules and non-terminal symbols. CFGs provide a structured way to generate sentences, right? Next, grammar-based text generation. CFGs are employed in text generation tasks where the goal is to generate grammatically correct sentences. By specifying the production rules, we can specify how to generate sentences that adhere to the syntactic constraints. This is useful, obviously, in applications, which we discussed earlier, but Specifically, grammar-based text generation process is used in applications like chatbots and dialogue systems and language generation models, etc. Right? Next, grammar checking and error correction. CFGs can be used in grammar checking and error correction to identify and correct grammatical errors, right, in text. By comparing the input text against a set of CFG rules, errors or inconsistencies in the sentence structure can be detected and appropriate corrections can be suggested and made. Language modeling. CFGs serve as the basis for probabilistic context-free grammars, which are widely used in language modeling. PCFGs extend CFGs by associating probabilities with each production rule, allowing for the generation of more realistic and fluent sentences. Linguistic analysis. CFGs provide a formal framework for analyzing the syntactic structure of natural language. By defining production rules and non-terminal symbols, CFGs allow linguists and researchers to study the grammatical properties and constraints of a language, leading to insights into the underlying linguistic structure. Therefore, CFGs obviously play a very, very vital role in NLP by providing a formal presentation of the syntax and structure of natural language. They enable various tasks, including parsing, generation, grammar checking, language modeling, and linguistic analysis, helping to improve the accuracy and fluency of NLP systems. Now, diving deep into parsing, which is one of the most prominent ways. One of the main applications of CFG in NLP is parsing, which involves analyzing the grammatical structure of a sentence. CFG parsers use the production rules to build a tree structure that represents the syntactic structure of the sentence. This can be used for tasks such as named entity recognition and sentiment analysis. Furthermore, NLP, as specified earlier, is subfield of computer science and artificial intelligence concerned with interactions between computers and human languages, right? So most common techniques as suggested is CFG, used which is used in NLP, right? And NLP is used for parsing sentences and analyzing the grammatical structure of the sentence. Many useful tasks this is used, right? This is useful, many useful tasks, and some of them being entity recognition, sentiment analysis, text classification, where parsing is used. With the increased amount of data generated every day, NLP has become an essential tool for businesses and researchers alike. Next up, what are the parsing processes involved, right? Some of the step-by-step overview of the parsing processes are first defining the CFG, where first the CFG is defined. That describes the syntax of the language we want to parse, and it also consists of the terminals and non-terminals. Next up being tokenization, where we basically break down the input sentence into tokens of words. Next up, we build the parse trees with the starting symbol of the CFG and recursively applying the production rules to generate parse trees. A parse tree represents the syntactic structure of the sentence. Each non-terminal is parse tree corresponding to the rule in the CFG, and the leaves of the tree represent the terminals or the words of the tokens. Top-down parsing. One common approach is top-down parsing, where we start the symbol of the CFG and try to match it to the input sentence. So this is done using the depth first manner, trying to expand the non-terminals until we reach the terminals that match the input tokens. Another parsing being the bottom-up parsing. So where we start with the input tokens and trying to build parse trees by applying the production rules in a right to left manner or left to right, depends on what is specified or what our approach would be. Error handling during the parsing, obviously, if the input sentence doesn't match to the grammar rules, or if there are inconsistencies or ambiguities, an error is typically reported. So final step being the semantic analysis. Once the process parsing is successful, we perform additional semantic analysis or build an abstract syntax tree to capture the meaning of the sentence. The specific details and complexities of the parsing process may vary depending on the chosen algorithm and the features of the CFG which is being used. Next up being grammar-based text generation with CFG. Obviously, this which we have discussed is very important. And another application of CFG in NLP is generation, which involves producing grammatically correct sentences. And this can be used to generate sentences by starting with non-terminal symbol and recursively applying the production rules until a terminal symbol is reached. This can be used for tasks such as dialogue systems and machine translation, right? So there are various approaches. where of generation in CFG, one being grammar specification, and which is the first step used to define the grammar rules that govern the generation process. It usually consists of non-terminal symbols and terminal symbols. Start symbol. Start symbol is chosen as the initial non-terminal symbol from which the generation process begins. Next is expansion and substitution. The generation process involves repeatedly applying the grammar rules to expand the non-terminal symbols until only the terminal symbols remain. And then the control mechanism. So obviously there are various control mechanisms which can be employed to influence the generation process. And one of them being these mechanisms obviously help in controlling the length of the generated text, in ensuring a certain level of diversity or enforcing specific grammatical constraints. Backtracking. Obviously, backtracking and pruning techniques can be applied to backtrack and explore alternative expansions or prune invalid branches during the generation process. And finally, once the generation process is complete, pre-processing steps can be applied to refine the generated text further. And yes, these systems are used in various applications and chatbots, which are like ChatGPTs and Google bots, some of the very recent applications, and obviously everyone knows about it. That's why I'm mentioning. And this is one of the uses, right? Applications, dialogue systems, language generation models, automated content generation. All these are used. By adhering to the predefined grammar rules, the generated text tends to be more coherent, grammatically accurate, and syntactically sound. Everything has its limitations, and even limitation of CFG exists. Though being a powerful tool, it has some limitations in NLP. For example, it cannot handle, the certain type of linguistic phenomena such as like long distance dependencies, ambiguity. And it is important to note that while these formalisms provide solutions to some of the limitations of CFG, they also come with their own set of challenges. But despite these challenges, the development of alternative formalisms has greatly contributed to the advancements of natural language processing and has opened up to new possibilities of understanding and analyzing the language. Finally, I would like to conclude for this presentation on the topic of, we discussed the CFG, the application of CFG in NLP, and its in addition to its applications in up parsing and generation. CFG is also widely used in natural language processing for various other tasks. So versatility allows it to be employed in tasks such as sentiment analysis, named entity recognition, and text classification. By leveraging the power of context-free grammar, NLP researchers and practitioners are able to develop more accurate and robust models that can handle the complexities of human language. As the field of NLP continues to evolve, it is expected that context-free grammar will play an even important and significant role in shaping the future of language understanding and generation. Thank you so much. This is all I had provided in this presentation, and I hope I justified. And everyone were able to understand the application of context-free grammar in natural language processing. Thank you so much. Naveen Shankar Choudhury here, signing off. Thank you.